In this lab, you're going to determine the activation energy that is required in the reaction between crystal violet and sodium hydroxide. So last week you did this experiment and determined the rate law. This week you're going to determine the activation energy. So as we mentioned in last week's video, do not pour the crystal violet and sodium hydroxide mixture down the drain. Make sure that you put that in the designated waste container. So for your experiment, you are going to set up your LabQuest following the directions in your lab handout, and then you're going to prepare some solutions at different temperatures. Now, you do not need to get the exact temperatures listed in your lab handout. In fact, that would be pretty difficult to do, to get exactly 10 degrees, 20 degrees, 15 degrees, 20 degrees, 25 degrees. You just need 4 different temperatures, preferably at least 5 degrees Celsius apart. You do want enough of a spread that you will be able to collect data and have some spread in between so that you can use that data to get the information that you need, but you do not need to get them in exactly 15, 20, 25, and 10. Just get 4 different temperatures. So a couple will be colder, one will probably be around room temperature, one will be above room temperature. Or you can do one below room temperature, one at room temperature, and a couple above room temperature. So once you have done that and you have collected your data, then what you're going to do is you are going to follow the directions in your lab handout to get natural log of absorbance in your LabQuest, and you're going to do that for 1/over absorbance as well, and determine your rate constant K for each one of your experiments. So once you have all of that data, then what you're going to do is you're going to determine the activation energy. So let's look at how you would do that. And we're going to use Excel because Excel will do some of this work for you, and then you don't have to try to do all this by hand, because you will need to create a graph and figure out the slope, and that's going to be a lot of work to do by hand, so we're going to use Excel to save us a little bit of work here. So in our first column, in column A, we're going to type in temperature in degrees Celsius. And I'm going to make this a little bit bigger, so we're going to, and I'm going to format that, and I'm going to superscript that so that that actually looks like a degree symbol. And then in the next column, I want to do temperature. So I'm actually going to add a column that is not listed in your lab handout, because this is actually going to make things a little bit easier. So temperature in Kelvin, and then temperature 1/over Kelvin. So now I don't have to have Excel try to do everything in one column. And then we're going to type in K. That's going to be your values that you've determined for K. And then in the next column, we're going to do the natural log of K. Okay, so that takes care of the columns that we need. Let's see. Okay, just making sure we have all our columns. So let's just imagine for a second that we did do 10, 15, 20, and 25. Just to make some examples here. So then what I'm going to do is to convert my temperatures to Kelvin, I'm going to type in equals, and the equal sign makes this a formula. So now Excel knows that it needs to do a calculation. And we're going to do this so that Excel does the calculations for us. So I'm going to click on this cell because I want it to take that cell and add 273 because that's how we get the Kelvin temperature from the Celsius temperature is our Celsius plus 273. And see, it does that calculation for me. Now what I'm going to do is I'm going to click on that cell and I'm going to get this little thin black plus sign. And I'm going to click that and hold it and drag it down. And if I do that, it's going to copy that formula and it's going to adjust it so it added 273 to A3, 273 to cell A4, and 273 to cell A5. So now it's done all the calculations for the temperature in Kelvin. And now I can tell it to take equals 1. So I typed in under the temperature 1 over Kelvin, I typed in equals 1 divided by cell B2. And I'm going to hit enter. And it does that calculation for me. So now all of that is done. So now I'm going to make up some K values here. Just because in order to do this, in order to show you how to make the graph, I need some values in there. So I'm going to make up some possible values for K here. So we're going to say for our first trial, let's just say our value for K came out to about 0.06. And then for our second trial, we got about 0.08. Our third trial, we got about 0.09. And then our fourth trial, we'll say we got about 0.10. Okay, just as some examples. So now what I'm going to do is I'm going to again make Excel do the work for me. So I'm going to take equals natural log, and now Excel knows that it needs to calculate the natural log of this number. I'm going to open a parentheses, I'm going to click the cell before it, and I'm going to close the parentheses. So you see Excel did that calculation for me. I'm going to get that thin plus sign again and drag it down. And Excel is going to do all that work for me. So now what I need to do is I need to plot 1 over Kelvin versus the natural log of Kelvin. So I'm going to highlight my column C, and then I'm going to hold down the control key, and I'm going to highlight my natural log of K column. And then I'm going to go to the Insert tab, and I'm going to go over here to where it says Charts. And under the charts, I'm going to click this drop down for the scatter plot. So when you put your mouse over it, you will see it says Insert Scatter. So I'm going to click that, and I'm going to select the first one that does not have any connections. So I'm going to click on that. And then I want to change the layout because I need to show my axes titles, because I need to label my axes in order to know what they are. So I'm going to select this first one that includes a chart title and axes titles. And then what I'm going to do is, it would be nice if this horizontal axis intersected the vertical axis. So what I'm going to do is I'm going to format the plot area. That doesn't take me to what I want. So let's see. Format axis. And I want this to intersect at the axis value. Actually, I think I need to click this one. So I want to bring that one down, which means I actually need to format the y-axis, and I need to change where it crosses with the horizontal axis. So I'm going to put in -3 because that's my bottom value there. And then I'm going to hit enter. And now I've just brought my bottom value down. So you can make your chart title whatever you would like to make it. I'm going to put activation energy of crystal violet. Okay. And you will need to make your own title there. Then my axis title, this is the temperature. So I'm going to put temperature, and then I need to include units. So your axis title must include units unless it is a unitless quantity. So if something is a unitless quantity, then you don't need to put units. But if your quantity has units, you must include the units in your axis title. So on this side, I'm going to do the natural log of k, and k is unitless, so in this case I would not put any units because that would be incorrect since k is unitless. But since temperature does have units, I do need to include the units for that. So then the next thing that I need to do is I need to put a trend line on here so I can find out what the slope is. So when I right click on one of these data points, I'm going to get a menu and I'm going to click add trend line. So my trend line needs to be linear, so I can leave this linear selected. And then I also need the equation, and I also want the r² value. So you can move this equation anywhere you would like. I'm going to move it up here so it's a little bit easier to read. You need the equation because you're going to need the slope in order to calculate EA. You also want to have the r² value because the r² value tells you how good of a fit this graph is. So if you get an r² value that's pretty close to 1, in this case we have 0.94, which is pretty good. If you get something that's way lower than 1, then that says that your slope, your trend line, is not a very good fit. And sometimes that's going to be the case because your data is a little bit all over the place, which may be indicative of some errors in your experiment. And that happens occasionally. But ideally, you're looking for an r² value as close to 1 as possible. So now we have our slope here. And our slope is given to us as -2793.6. So we know from the Arrhenius equation that the ln of k1 over k2 is equal to -EA over r times 1 over T1 minus 1 over T2. So if we plot Kelvin versus temperature, then our slope, which we represent as m, is equal to -EA over r. So then we can rearrange this to get our activation energy is equal to our slope that we came up with from our graph times the negative of r. So then what we can do is we can plug in the slope that we came up with. So you're going to plug in the slope that you got from your graph, and R is 8.314 joules over Kelvin times mole, but we need to make that negative in order to get our activation energy to be positive. And we know that we also typically express activation energy in kilojoules, so you will also need to multiply by the conversion factor to convert your activation energy to kilojoules. So this is what you're going to do with your data once you have all the data for your activation energy in order to calculate your activation energy. So make sure that you have submitted your purpose and procedure on Canvas, and I will see you in lab.